Welcome back to Keys Precalculus section 4.5. I'm going to do an example with you. I was able to free up some space on my computer, so anyway, so I can finish this example. Your homework is going to be similar to this. Sometimes you're just finding amplitude, sometimes you're just finding period, sometimes you're going to be graphing. So I figured if we just graphed one of these problems together, you'll see how it works. So I have the basic sine wave, or the sine function graphed up here in red, which again, my period is 2 pi, which you can see on the graph. My amplitude is 1. This is just the basic sine graph that we had been looking at before in the last video. But right now, we are going to graph some translations on it in purple. So we're going to graph the function y equals 7/5 sine of 2x minus pi. And we're going to apply the translations we learned from the last video to it. We're going to find A, the amplitude, B, the period, D, the vertical shift, and then lastly C, the horizontal or phase shift. So the first thing we're going to do is find the amplitude. And remember, the absolute value of A is equal to the amplitude. The absolute value of A is really saying the absolute value of 7/5, because 7/5 is in the A place. The absolute value of 7/5 is 7/5. So my amplitude is going to be 7/5 for this new graph. It's convenient that my little squares are in blocks of 5. So 5/5 is at the 1. The 7/5 is 2 little blocks above it. That would be going from the x-axis up to 7/5, and then down from the x-axis down to 7/5. And then back up here again. And oh, I forgot to say, we're going to graph 2 full periods when we graph this. Okay? So my amplitude is 7/5, and I've marked where it would be, but it's not going to be exactly there because we're going to be shifting it too. It's up here. Right, it's going to be shifting, so it's not going to be exactly where I have those dots. It's going to shift over. But before we do that, also we're going to have to figure out our period. So our period is set with the letter B, which is the coefficient of x, which is 2. That affects our period. We find it by taking 2 pi and dividing it by B. 2 pi, and we'll do this every time, because 2 pi is our normal period for sine, divided by 2 gives us pi. So that means my period is going to be shorter. It's going to go from 0 to pi instead of from 0 to 2 pi. That means in 2 pi, I'm going to have 2 full periods. So I would have it at 0 all the way to pi. Halfway through is 2 pi, and halfway between 2 pi, or excuse me, pi over 2, halfway between pi over 2 and 0 is pi over 4, which would be, my amplitude would be up there. Then halfway between there and there would be, my amplitude would be down here. So this isn't the graph yet because I haven't put my shifts in, but this would, if I didn't have shifts, this graph that I'm trying to lightly sketch here, that would be 1 period, and then I would do it again over here. This is halfway through, this is 2 pi. Halfway between pi and 3 pi over 2 is 5 pi over 4, so I'm going to go up here, and then 7 pi over 4, which would be down here. So I could do another cycle or another phase. So see, I've done 2 periods, and 2 of them fit in one of the original periods of pi. So I know that that's not pretty, but that's my temporary graph of y equals 7/5 sine 2x minus pi. But because I have, well, I have no d, I'm not adding or subtracting anything to the total function, so there is no vertical shift. So I'll write none here. So there's no vertical shift, but there is a horizontal shift. And I'm going to have to figure that one out. And I'm going to do that down here. So remember, my left value, or my beginning point of the horizontal phase, my left value is at C over B. Well, my C is pi. It's not negative pi, it's pi. So it's pi, and my B is 2. So pi over 2 is my leftmost phase shift. So instead of starting at 0, my cycle or my phase is going to start at pi over 2. My rightmost endpoint is going to be, for one cycle or for one phase or one period, is going to be 2 pi. That would be my original, plus C, over, I'm dividing by B, which is 2. So it would be the same as saying 2 pi plus pi, which is C, over 2. And when I add those together, I get 3 pi over 2. So that is going to be my rightmost value of my phase. So instead of starting at 0, the first part of my phase is going to start at pi over 2. And it's going to end at 3 pi over 2. So I know that halfway through is pi. So then halfway between pi over 2 and pi is 3 pi over 4, which is here, and I'm going to go all the way up to my amplitude. So this will be my dot here, and then down halfway between pi and 3 pi over 2 is right here, all the way down from my amplitude. So then what I'm going to do is trace, but I made my marker a little thicker so it'll show darker here. So there's one period, and then I need to do it again. So pi over 2 to, it would be 5 pi over 2. So this would be halfway 2. Because remember, it's going to fit, two of them are going to fit into the period of 2 pi, because the period is no longer 2 pi, it's pi. But I'm shifting it, so it's going to be up here. And I'm going to have to put dots where my right, down here. I keep having to stop the video to find my pen again. It's really hard to see. Okay, I'm going to clean up some of this stuff so you can see. Tried to clean it up a little bit. I know it's still messy because I'm doing this by hand on the computer, but you can see how I've taken my original sine graph, which is the red one, y equals sine of x, and I've used translations to graph y equals 7/5 sine of 2x minus pi. Now this is just 2 periods. It would continue forever on the right and forever on the left, but I just had to draw 2 periods. We're going to go to Desmos now so you can see an actual cleaner version of this. So here we are with my original graph of sine of x, and if I plug in, let's see, the graph I just drew on the other piece of paper, or other screen on the computer, you can see this is a much cleaner version of that. You can see that I've got my original period of 2 pi, but the new period is going to be half of that. So I can fit 2 of them into one phase. But I'm shifting it over. So instead of starting at 0, I'm starting here at pi over 2. So I'm going to shift. I'm going to do 1 period and then 2 periods where it would have been 1 period originally. And it shifted right pi over 2 radian, or 90 degrees. All right? I hope this example will help you figure out what you need to do for your homework. I also put in the files section of Canvas on our classroom a document, a PDF of the notes that are 2 pages of the notes that I gave you earlier in the earlier video. It has all of the translations on there, so you can use that. You can print it out and use it kind of as a cheat sheet to help you sketch these graphs as well, to help you figure out what the amplitude is, what the phase shift is, and what the period is. All right, I'll see y'all on Thursday.